This lesson is on solving equations with variables on both sides. It's lesson 28 in your book on pages 164 through 170. When you have an equation with variables on both sides of the equal sign, the key is to get all the variables to one side, and we're going to do that using opposite operations. So here we have an equation, 4x plus 5 equals 2x plus 11. This is an example that needs to be in your notebook. We need to move all the x's to one side. So we can either move 4x to the right side or 2x to the left side. Now I'm going to move 2x from the right side to the left side. Since it's a positive 2x, and I'm adding positive 2x plus 11, to move 2x to the opposite side, I'm going to subtract 2x from both sides. When I do that, I have 4x minus 2x, which gives me 2x, plus 5, equals, and then 2x minus 2x is 0, plus 11. Now from here, it's just solving a two-step equation. So 2x plus 5 equals 11. Normally, I would multiply by 2 and then add 5. So here, I'm going to subtract 5 from both sides first. I can bring down my 2x. Positive 5 minus 5 is 0, and 11 minus 5 is 6. And then finally, since I'm multiplying 2 times x, I'm going to divide by 2. My 2's cancel, and I'm left with x equals 3. Now I could check this by plugging 3 into my original equation for both of these x's, and I should get a true statement, like 17 equals 17. Here's another example that needs to be in your notebook. We want to solve and check. So 6x equals 4x minus 10. Again, I want to get all my x's, all my variables to one side. So I either need to move the 6x over here to the right side or the 4x over here to the left side. Now, since we're trying to get that x away from everything else, I'm going to subtract 4x from both sides. I'm subtracting because it's positive, so it's positive 4x minus 10, so I'm subtracting it to eliminate it. 6x minus 4x gives me 2x. 4x minus 4x is 0, and then I have negative 10. Now, if I knew what x was, I could plug in x here, and I would multiply 2 times x. So to get rid of the 2, I'm going to do the opposite, and I'm going to divide by 2 on both sides. Now my 2's cancel here, and I'm left with x equals, and negative 10 divided by 2 is negative 5. So here's my solution. It also says to check it. So I'm going to plug negative 5 in for both x's in my original equation. So I have 6 times negative 5 equals 4 times negative 5 minus 10. Now I know 6 times negative 5, it's a positive times a negative, which makes it a negative, and then 6 times 5 is 30. 4 times a negative 5 is a negative 20 minus 10. Negative 30 equals, negative and a negative are going to give me a negative, and 20 plus 10 is 30. So I have negative 30 equals negative 30, which is a true statement. Anytime you check an equation with multiple variables in the equation, you plug in this value of the variable everywhere you see the variable. So that's why I had to plug in negative 5 in both places that I saw this x. Here's another example that needs to be in your notebook. In this example, we're going to simplify before solving. So before we get all our variables on the same side, our life is going to be much, much easier if we simplify first. Now, on the left side here, and then also on the right side, I have a situation where I can apply the distributive property, and I can multiply 5 here by each term inside my parentheses. 5 times 2x gives me 10x, plus, right there, 5 times 4 gives me 20, and then I have my minus 2x. Now on the right side, I've got 2 times 3x, which gives me 6x, plus, and then I multiply 2 times 12, which is 24. So my first step that I did here was distributing on each side to make this a little bit simpler. Now notice that on my left side here I have 10x and negative 2x, and those are like terms because they have the same variables to the same power. So I can combine 10x minus 2x is 8x. And then I've still got that plus 20 there. On the right side, I have 6, which is a constant, and 24, which is a constant. So I can combine those. I still have my 6x, and 6 plus 24 is a positive 30. Now notice that this one looks a little more like the first equation. So I want to get all my variables to the same side. So I either want to move 8x to the right side or 6x to the left side. I'm going to move 6x to the left side. So to get rid of my positive 6x, I'm going to subtract 6x. And if I do that to the left side or right side of the equation, I have to do it to the left side also. So I have 8x minus 6x, which is 2x, plus 20, equals 6x minus 6x is 0, and then I've got 30. Now again, it's one of those easy two-step equations. If I was going to plug a number in for x, I'd multiply by 2 and then add 20. So I'm going to do the opposite, and I'm going to subtract 20 and then divide by 2. So first I'll subtract 20 from both sides. When I do that, I'm left with 2x, and then 20 minus 20 is 0, equals 30 minus 20, which is 10. Finally, since I'm multiplying here 2 times x to get rid of the 2, I'm going to divide by 2, both sides. And that leaves me with x equals 10 divided by 2, which is a positive 5. There's my solution. Now, if I plugged positive 5 in for x here, and here, and here, I would get a true statement, which is what shows me that that is a solution to that equation. Alright, so now we need to talk about identities. An identity is an equation that is always true. An identity has infinitely many solutions. So if you are solving an equation, and instead of getting x equals some number, you get something that is a true statement, like 2 equals 2. That means that that equation has infinitely many solutions. It implies that no matter what you plug in for the value of the variable, you will get a true statement. Now, on the other hand, if you get a false statement, such as 2 equals negative 4 or 1 equals 3, and no value subbed in for the variable makes the statement true, that means there is no solution for that equation. Let's look at one of those. Okay, so here we have an equation, an example. It needs to go in your book. We have 10 minus 6x equals negative 2 times 3x minus 5. Now notice we can use the distributive property here, so that's what I'm going to do first. I'm going to do negative 2 times 3x, which is negative 6x, minus negative 2 times 5, which is negative 10. Alright, so 10 minus 6x equals negative 6x minus a negative 10. Now we can simplify that, minus a negative. So we have 10 minus 6x equals negative 6x plus 10. Again, we want to get all the variables on the same side. So we can either move negative 6x to the right here or negative 6x to the left here. Now, since it's minus 6x, to move it, I'm going to add 6x to both sides. Now I've got my 10 right there. Negative 6x plus 6x is 0. Negative 6x plus 6x is 0, and then I've got 10 on this side. Now notice I didn't come out with x equals some number. It's just 10 equals 10. That is a true statement. Since we solved and didn't get x equals a number, but we got a true statement, that means there are infinitely many solutions. So I'm going to say infinite solutions is my answer. That means that no matter what value I plug in for x, the equation will still be true. Again, here's another example. This needs to be in your notebook. We want to solve and check this equation. 7x minus 2 equals 9x minus 5 minus 2x. Now, on this right side here, we have 9x and 2x, which are like terms, so we can combine them. The left side stays 7x minus 2. 9x minus 2x is 7x. And then we have minus 5. Now we've simplified, so we need to move all the variables to the same side of the equation. So I'm going to subtract 7x because it's positive, so if I subtract it, that will eliminate it. Subtract 7x from both sides of my equation. 7x minus 7x equals equals 0, and then we've got our negative 2 right there. 7x minus 7x is 0, and then we've got negative 5. Again, I don't have x equals some number. I have negative 2 equals negative 5. We know that that is false. Negative 2 never equals negative 5. So that means that there is no solution to this equation. No matter what value of the variable we plug in, we will not get a true statement. And here's our final example that needs to go in your notebook. Telephone company A charges $18.95 per month for local calls and 4 cents per minute for long-distance calls. Telephone company B charges $21.95 per month for local calls and 2 cents per minute for long-distance calls. For what number of minutes of long-distance calls per month is the cost of the plan the same? Okay, so we know telephone company A is always going to charge $18.95, and they're also going to charge 4 cents per minute for long-distance calls. So we're going to have to add on the 0.04 times the number of minutes of long-distance calls. So they charge the flat rate plus 4 cents per 4 times minutes. Phone company B charges the $21.95 for local calls, and then they charge 2 cents per minute for long-distance calls. So they also charge 2 cents per or times the number of minutes of long-distance calls. We want to know when these two prices, when these two costs are going to be equal. So we're going to set these two equations equal to each other. $18.95 plus 0.04m equals $21.95 plus 0.02m. Now we need to solve for m because we need to know for what number of minutes for long-distance calls is the cost the same. So I need to move all my variables to one side. In order to do that, I'm going to move 0.2m to the left side. Since it's positive, I'm going to subtract 0.2m from both sides. I'm sorry, 0.02m. Alright, now 0.04m minus 0.02m gives me 0.02m. So I have $18.95 plus 0.02m equals $21.95. Now these are going to cancel. There's 0. Now to solve this, I need to subtract $18.95 from both sides. So I get 0.02m equals, and then $21.95 minus $18.95 is $3. And then finally, to solve for m, I need to divide by 0.02. So 3 divided by 0.02 is 150. That means that the cost of the plans is the same when the caller has used 150 long-distance minutes.